lot. So if you watch the complete video, then you will be aware of all the operations. So we will be talking about Numpy. So first thing you have to do is import Numpy as n, and you will run it. So there is no error. It means this Numpy library is now loaded. If Numpy library is not loaded, then you will get error. Then you can install it by simply following the install commands. So there is no error. It means Numpy is loaded in our system. Now we can create arrays. So suppose we are creating a 1D array. So you can do it by simply np dot array, then you will have circular brackets, then you will have curly brackets. So when run, so it is created a Numpy array, and you can see the type. So write just print then type of A. So you can see this is the Numpy array, and you can see the shape of this also. So A dot shape. So shape is, it is a 1D array, okay, and it has 2 columns. So this is how you can see the shape. Now suppose we are having a 2D array, so you can add more elements to it, say 3, 4, and so you need square brackets, and then in these square brackets you can have these rows. Now this is a 2-dimensional array, so this is having 2 rows and 2 columns. Okay, so this is how you can find the shape of the arrays, and you can extract the individual elements of this array. Suppose I add one more element, say 7, and here say 9. Now I want to extract, say, this first element. So this is on the first row and first column. So first row, so you should note that in Numpy the index starts from 0. So first we are having 0, then 1, 2. Similarly for columns. So this is the first row, means 0th row. Sorry. So you need to write it here. So 0th row and 0th column. Okay. So this is extracted. Now you want this element 2. Then what you should do, 0th row and first column. Okay. So in this way you can obtain individual elements, and you can obtain multiple elements also. So just copy this, and now suppose you want this row in the second row, and this element. So simply run this, so you will get 3. So in this way you can extract individual elements. Now there are some special arrays which we will talk about. So like array of ones. So for this, what you will do, you will write np dot ones, and then you will write the dimension, So suppose we want a 2 by 2 array. So actually, so this should be the command lines. Now these statements will not be executed. So now we will see B. So you can see that it has created the arrays having ones and dimension is 2 by 2. Similarly, you can have 3 by 3. So now it has created a 3-dimensional array, 3 by 3. Similarly, you can have some, if you want with some say constant values, then for that you can write here full and say I want 5. Okay, so it will create arrays of 5, arrays of 3 by 3 with values 5. Similarly, you can create arrays of zeros. So np dot zeros. Okay, so sorry, I need to delete this. So similarly, you can have some different dimensions, say 2 by 3. So this is how. Then you can create a random array, means arrays having some random values. So you have to write np dot random. So you have to write it 2 times. Okay. Now you can get array of random values, and suppose you will run again, then you will get some different values. Okay, so each time you will run this, you will get some different values. Okay, so this is how you can get a random array. Then there is another useful array, I. So for I you only need this 1 dimension here in the bracket. So and I will create an array which is having 1 at this diagonal, and all other elements are 0. Okay, so at the diagonal you will be having 1 and all other elements are 0. So this is how this I will work. Now the one array which you often use in your program is lin space. So suppose you are having a and np dot lin space, and then what you do, you will write the starting value, say 1, then you will write the last value, and then you will write the total number of values. So my starting value is 1, my last value is 10, and I want total 10 values. Okay, then I will get an array of, say, this is my starting value, this is my last value, and this is the total values. Okay, suppose if I want total values as 5, then I will get this array. So this is my starting value, this is my last value, and I have total values 5, 1, 2, 3, 4, 5. So this is how this linspace command works. So this is very, very important, especially in writing the machine learning codes. Then another important feature is slicing. Okay, so means if you want to slice the different elements. So suppose we are having a one-dimensional array, np dot array, and say we are having 1, 2, 3, 4, say 5, and I want to slice this A. Okay, so The slicing, I will write the starting index. So say I am selecting the starting index as 0, then final index up to which I want to go, say I want to go to up to 6, and then how much I want to skip. Okay, so if I write 1, then it will not skip any element. Okay, so my starting is this, and I want till last, and I don't want to skip anything. Now if I write it 2 here, then I will be skipping one element. Okay, now when I run it, so this is my starting 0, and I will skipping one element in between. So this is skipped, then I will reach to the 3, then this is skipped. So this is how this slicing operation will work. Now let us see how to use this operation in a 2D array. So suppose I will make a multi-dimensional array, and suppose this is my 5, 6, 7, 8 and 9, then 10, 11, 12, 13 and 14. So I am having this. So this array has 3 rows and 5 columns. So this is my array. Now I want to slice some elements. So say I write it as B, and I want to slice from A. Okay. Then suppose I write it as this and this. Okay, and then I will run it. So there is some error. Okay, so I forgot to bring a square bracket here. Okay, now it's fine. Okay. So now what this slicing is doing, so it has extracted this 1, 2, 3 rows like, and this 6 to 7. Okay, then now I've changed it as 4. So it is skipping means sorry, 1, 2 and 3. Okay, similarly 1, 2 and 3. So up to 2 rows it is slicing. Now if I write it 1, so you will get from only first row. Okay, if you are writing it 2, then you will get from both rows. If you write 3 here, then you will get from all the 3 rows. Okay, and this is concerning the columns. So this is 0, so it is not getting, so it is getting from 1 to 4. So 1, 2 and 3. Okay, if you write it 3, so you will get only these. So 1 and 2, so you will get value between this. Okay, so this is how this slicing operation will work. So from here you can select how much rows you want to slice, and from here you will select the number of columns. Similarly, you can have some Boolean operation also. So I am just copying it. and say some boolean. So suppose this is my A, and I want elements that are greater than say 5. Okay, so in this all the elements are less than 5, so we are getting all the false values. Then this is also less than 5. Okay, so this is also false and all other are true. Now suppose if I change it to 10, then it will give the greater than 10 values. Now you can also do some math. So once again I will copy this and paste it here. Okay, and I want to do some mathematic operations. Okay, so array math. So once again I am copying this, and suppose this is my array number B, and suppose I want to change these elements. Suppose this is 11, this is 12, this is 13, this is 14, this is 15. Okay, just adding 1. So let us keep it same. Now if you want to add, then what you will do, say print just A plus B. Okay, so it will add the corresponding elements. So 1 and 11 will be added, 12, then 2 plus 12. Similarly you can have the subtraction, so the corresponding elements will be subtracted. So here since we have the same elements in this last, so you will be getting 0. Okay, so this is how you will perform the math. Then similarly you can do the dot products also. So for that you will write np dot and a comma b. So this is how you can perform the dot products, but for that the size should match. Okay, so because our sizes are not matching, so let us make the same size. So I will be making it 2 by 2. Okay, just wait a minute. So now this dot product is performed. So the size should be the means according to the dot product. So this is how you can perform operations on Numpy arrays. Then you can last is the loading and saving of the files. Okay, so just put a hash here to make it the command line. Now suppose you want to load some file, so what you will do, np dot gen from txt, and then you will write the name of the file here. Suppose name of the file is f.csv. Okay, so you will write in the columns. Then what is your delimiter? Sorry, delimiter. Sorry, this and again this should be in your inverted commas. Okay, and then if you want to skip header, because every file have some header, so you will write this header is equals to 1. So then this will read the file, so you have to give the location, and then this will read the file. Similarly, you can save the file. So for saving, again, what you will do, sorry, this header spelling, please correct it. Okay. Now you will do np dot save text. So whatever format you want, so if you want to text, then this txt, and then you will write the, suppose your array is a, and you are having some array, sorry, so you are having some array like 1 2, so you will write the array here a, and in the last you will write here delimiter. Okay, so just I am copying it from here. So it will write at the default location, or if you want some particular location, then you have to give the location here. Okay, so this is how you can use NumPy arrays. So in the next video I will discuss another important machine learning package, that is pandas. So have a nice day, and if you like my video, then please subscribe, give a thumbs up. Thank you very much.